In this video, we are going to show how we can determine the molecular formula from the name of an ionic compound. In our last video, we talked about how to name ionic compounds when I give you the formula, but this time we're going to be going in reverse and being given the formula, or being given the name and transcribing it into the formula. It's important that we can go both ways because it wouldn't make sense for us to only be able to tell the name from the formula. Obviously, the name has to hold some sort of meaning so that we can know what the formula is from the name. And we said in the last video that it's pretty easy to determine the name of an ionic compound because all you're doing is just putting down the two elements and then replacing the ending with "ide." So cut off the ending and replace it with "ide." But it's going to be is going to make it a little more challenging in order to go backwards because we're going to have to figure out how many of each element there are. There's no descriptor here telling us how many fluorines we have. We have to figure out that there are 2 fluorines in calcium fluoride, for example. But I'm going to show you exactly how to do that here in this video. So, and actually let's go back to our first concept where we talked about just what an ionic bond is. We said it's the complete transfer of electrons between elements when we form a compound. So we said that, like, for sodium chloride, we transferred 1 electron to chlorine to form sodium chloride because now sodium got rid of its valence electron, getting rid of this outermost electron in order for it to get to 8. And then chlorine gained an electron, so now it has 8 valence electrons. They both have 8 valence electrons by sodium giving 1 away, and that's how they form sodium chloride. But we said that it doesn't always just match up 1 to 1. Sometimes we might need 2 sodiums to react with something for both to get to 8. So in this example, we said sodium reacts with oxygen. We need 2 sodiums to react with oxygen. Because oxygen has 6 valence electrons, it needs to gain 2 electrons. So each sodium has 1 to give, so we're going to form Na2O, sodium oxide, by having 2 sodiums both give their single valence electron to oxygen to form the ionic compound Na2O, sodium oxide. So it's not always a 1-to-1 ratio. Sometimes we need more of one element or more of both elements, as we'll do in further examples. But we said that the way we determined that we needed 2 sodiums is because oxygen has it needs 2 valence electrons, and sodium only has 1 to give. So we need 2 sodiums in order for this to all balance out and for sodium to get rid of both of its electrons and oxygen to accept 2 electrons. Remember, oxygen's not interested in accepting only 1 electron. It's only interested in accepting 2. So let's do some examples here and show what's going on. So we're going to be kind of doing the same thing we did from the start in that first video. So let's come up with an example on the periodic table. Let's look at, let's do magnesium and chlorine. All right, so let's try magnesium and chlorine, and let's see how they're going to bond together in order to form an ionic compound. And so we're going to start by drawing the Lewis structure for each. So we're going to have magnesium and chlorine. We're always going to start, or at least if you're doing it in this method, you're going to start by drawing the Lewis structure for each of those compounds. So chlorine has 7 valence electrons, and magnesium has 2 valence electrons. And then we said it's the transfer of electrons is what an ionic bond is. It's a complete transfer of electrons. Magnesium needs to get rid of 2 electrons to get to 8 valence electrons. And then chlorine needs to gain 1 electron to get to 8 valence electrons. So magnesium has 2 to give, and chlorine can only accept 1. So how can we get around this? Well, we could just add another chlorine. And that's the only way that chlorine's going to want to bind to magnesium. Because, again, magnesium's not interested in only giving away 1 electron. That doesn't help it at all. It needs to get it's 8 or bust. It's only interested in getting to 8 valence electrons, not interested in getting to 1. So magnesium can give away 1 electron, and I'll just do it in the same color. Magnesium can give away 1 electron to this chlorine, and then magnesium can give away 1 electron to this chlorine. And now that magnesium gave away both its electrons, it now has 8 valence electrons. And now that this chlorine accepted 1, it has 8, and this chlorine accepted 1, it has 8. So when everything has 8 valence electrons, or I guess more accurately, when everything has a full valence shell, then they're happy and you formed the ionic compound. When we count how many total of each element that we have, we can determine the molecular formula. So magnesium, we have 1 magnesium, and for chlorines, we have 2 chlorines. However, there's no need to write the 1. If there's only 1, if there's only 1 of an element, don't write a number in the subscript. So if I haven't made it obvious, the number in the subscript designates the number of each element. So the number directly to the right and in the subscript, so at the bottom, tells us the number of each element. So Mg, and actually let's convert this to how we would write it correctly in this class or any chemistry class. I guess you're not wrong if you write Mg1Cl2. But nobody ever writes the 1. It's typical notation to not write the 1. If there's only 1 of an element, we're going to not write a number in the subscript for that element. So Mg1Cl2, that's going to be more commonly written as MgCl2. So this tells us, since there's no number written here, that tells us there is 1 magnesium. And for chlorine, we have a 2 written next to it. So that tells us that there are 2 chlorines. So MgCl2, and then we learned in the last video that this would be called magnesium chloride. Because magnesium is the element, chlorine is the other element. We dropped the ending and replaced it with "ide." All right, let's try another example. And actually, before I do another example, let's show how to draw this. So magnesium and chlorine. Magnesium gave away its 2 valence electrons. It now has 8 valence electrons, but for whatever reason, when we're doing a Lewis structure and something gives away its 2 valence electrons, we're going to draw it as if it doesn't have any valence electrons. Why we do that, I'm not completely positive, but that's just probably just because it looks a little more clean. If something has, for the most part, nothing's going to have 0 valence electrons. If we have 0 drawn, then I guess we're going to assume that it has a full valence shell of 8. So magnesium, we're going to write this like this. So I'm going to draw magnesium in the center. And then I'm going to have the charge. And I draw it in, whenever there's a charge on a Lewis structure, we're going to draw brackets. So magnesium, it lost 2 electrons. And when you lose electrons, you're going to have a positive charge. And how many electrons did it lose? It lost 2. So we're going to have a positive 2 charge. Chlorine, we're going to draw chlorine with all of its electrons. So I will draw chlorine with all of the electrons it has. And we said that it gained 1 electron. So I'm going to go back and change this to actually drawing it in the color, colored, so that I can represent that this electron right here came from the magnesium. So chlorine, we said it normally has 7 valence electrons, but it gained 1 valence electron. So we're going to draw this as chlorine with it gained 1 electron, and when you gain an electron, you gain a negative charge, so there's a -1 charge. And then on the other side of the magnesium, I'm just going to redraw the chlorine. So I'm just going to copy and paste it actually. And then boom, that's how we're going to draw the Lewis structure for ionic compounds. We're not going to draw it as a line because we're going to leave lines to represent the covalent compounds and covalent bonds. Ionic compounds, remember, it's a complete transfer of electrons. So really, instead of drawing a line, the reason why we're drawing it as just these ions that are just next to each other is because, again, we said it's a complete transfer of electrons. A line kind of would make it look like, if I drew it as lines, that kind of makes it look like they're sharing the electrons. But again, in ionic compounds, there's no sharing of electrons. It's a complete transfer of electrons. These red electrons that I have drawn, these used to be the magnesiums, but now they belong to chlorine because magnesium gave away the electrons. So that's why we're going to draw ionic compounds as these brackets with charges instead of drawing it with lines, as we'll show how to do when we go over covalent bonds. So this is not how we're going to draw an ionic compound. We're going to be drawing them like this. All right. I'm going to end this here, and then I'm going to do another video with some more examples. So hopefully this is helpful. Let me know if you have any questions.